Hey level chemists, let's try and do this in under a minute. Simple Born-Haber cycle, easy 4 marks to get on an exam. Okay, so immediately I'm thinking here, if you don't know what to put, formation is a good idea normally. So we know that we need 2 potassium as it's K2O, so we're going to need 2 moles potassium. We also know that potassium is a solid in its standard state, and we know that oxygen is O2 in its standard state, and it's also a gas. But if we also look up here, we have 1 mole, and also down here we have 1 mole. So we need half an oxygen molecule. And we can also see here that this will be our standard enthalpy change of formation, as we're forming 1 mole of a compound from its elements in their standard states. Okay, let's have a look up here. What do we have? We've got K, S, and O going to 2K plus O gas and 2 electrons. So here I can see this is the first ionization energy of potassium. But we also, what my advice would be is look at the state symbols. So we've got O, which is a gas anyway, that's fine. But look, K is going from a solid here to a gas. So we need the atomization of potassium, which is going to be 2K G plus OG. Okay, so let's have a look at what we've got here. So we here have the atomization of oxygen as we're forming 1 mole of O, and here is the atomization of potassium. Bear in mind that if it asks you to do a calculation after this, you would have to times it by 2 because of the 2 moles of potassium. So you'd have to times atomization of potassium by 2. And I said here already, it's the first ionization energy of potassium. Okay, and here we need to be thinking of electron affinity. So this is going to be the lattice enthalpy where I've written X here, and that's probably what they'd ask you to calculate in in an exam. What we know about lattice enthalpy is it is the enthalpy change when 1 mole of an ionic solid is formed from its gaseous ions. So that means up here, we're going to need gaseous ions forming K2O. So we're going to need 2K plus O2 minus gas. And we know that we're forming an O2 minus ion, which means for our final gap here is going to be the electron affinity of oxygen, the first electron affinity, because this here will be the second electron affinity. So we're going 2K plus, which will be unchanged, plus O minus. What we're doing here is we're absorbing 1 of these electrons. So we're still going to have 1 left over, which will be used up here. And there we go. There's your 4 marks.